Here I'm gonna talk about the strength and the weakness. So first I'm gonna talk about three things. One is the data authenticity. That this paper is based on 118 real-world data set rather than the generated data. And the methodology foundation is strictly allows Jim grades for criteria and the Harvard level insight. This paper used the profiling to pinpoint the CPU bottleneck, like I mentioned earlier. And following that is a weakness, the potential home field biases. The queries were generated by the authors on tool like AutoML, which may favor OpenMLDB architecture, since it is to finding the pattern that might be helpful in the data model already familiar with already. And the following that is the correctness of the gap. Paper has addressed heavily on speed-wise topic, the latency, while it is also important to talk about the accuracy of the extracted feature, such as the viral bank cases. It misjudged cause the financial losses. And that is the logical concern. So since the ML is relies on the history patterns as the algorithm training, what would be happen when there is a counterfactual cases show up, like new unexpected behavior, the statistical feature might go wrong. So, following that, I'm gonna talk about my concern. So the auto ML robustness concern is about I'm gonna talk about from the how it works and why it deserve a concern. So the auto robustness concern, we need to understand how the test query were made. The author used auto ML, a field designed to increase efficiency and make AI accessible. Um, um, to like non-expert by automating feature engineering. So um, then in the FE bench, in step three, the FE bench workflow, they use a feature emulator. It uses an algorithm called Bing search to find the feature that maximize AUC, which is the score of how accurate the AI was on the history data. So as a student learning, the new to coding and the software field, my concern is that is this method rely on the statistical result like correlation? It's not logic. And you assume that because a pattern existing in this 118 data set, it will always exist in the future. Um, this create a trap or concern where the system is very fast, but potentially be wrong if the new coming feature will be changed, like new data, like unusual activity. So to make my concern clear, let's look at this counterfactual example involving uh, the Q5, like fraud detection in the paper. Um, In historically, fraud might involving talking a large amount of money at once. So the auto ML tool create a feature to watch the high transaction amount. But what if the fraudster becomes smarter and does something that AI doesn't never seen? For example, make it 100 transaction of only $1 each because the auto ML was only looking for pattern in the past data. So it feature my completely missing this new behavior. This is why we need logical uh, uh, like rules for this. So a simple rule like more than 220 transactions per minute is a solid logic that protects the bank even when the AI statistical pattern falls. So maybe like some test case is important here. So every bench measure how fast we extract a feature, but it doesn't yet measure how logical solid these features are and when facing the unknown. So that is my thoughts. So to conclude, I would suggest improvement that align with my own journey as a new comer to the software world. According to the AutoML systematic review, a major goal of this field is the democratizations of machine learning. So by using the paper's 118 real-world data set and its reusable simulator components, a beginner like me can explore the overall picture of machine learning. It allows us to see exactly how raw data is transformed into this feature that drives AI prediction. So beyond just learning, I want to use this pipeline to evaluate the resilience of this model itself. As I mentioned in my critique, most AI today might face the statistical trap built on the past. So therefore, I can see maybe we can do some like counterfactual stress tests. Maybe I can build my own model and also explore more, like to plug into this FE bench and challenge it with new behavior that contradict the history data. So in conclusion, we should measure more than just latency. We can also measure logical resilience. My goal is to use this tool to ensure the AI we build in the future is not just fast, but also logical, solid enough to handle the unpredictable uh, things in the real world. Yeah, so that's everything today. Thank you.